So let's zoom in on fermentation. That's where you're actually growing these organisms. How do these containment principles apply right there at the start? Must be some unique challenges.
Oh, absolutely. That's where the proactive design really kicks in. Fermentation is, well, the growth phase, so containment is just paramount right from the outset. The design of the fermentation vessels is key. As we mentioned, they're engineered as sealed systems, purpose-built to keep the microorganisms and the growth media inside. That protects the environment, protects the workers, and also prevents contamination getting into the culture.
Right, protects the product too.
Definitely. And they have built-in safety features, things like pressure relief valves. Fermentation can produce gas. Pressure builds up. These valves prevent the vessel from, well, rupturing, which would be a major containment failure.
Yeah, catastrophic.
And you'll often see secondary containment trays, like a bund wall or a pan, built right under the vessel. Just in case there's a leak or a spill, it's caught immediately.
It's interesting, actually, how much thought goes into planning for potential failures.
Well, the use of bioreactors is central. They are by nature closed systems. They maintain very specific conditions, temperature, pH, oxygen, perfect for growing the microbes. Because they're closed, they inherently help with containment. Keep things in, keep contaminants out. And critically, before you use one and after you're done, there are strict sterilization protocols, like steam-in-place sterilization. Cleans everything, kills contaminants, prevents carryover between batches.
And handling the actual microbes, transferring them, and so on.
That demands incredible care. Handling of microorganisms relies heavily on aseptic technique. Everything's sterile. Sterilizing equipment before and after, working in sterile environments like those biosafety cabinets we talked about, following very precise steps for every transfer.
Those cabinets again.
Absolutely essential. They provide that enclosed, sterile workspace. And the HEPA filters in them protect the operator from any aerosols that might be generated during handling. It's meticulous work.
Okay, so we've grown the organisms safely in fermentation, but then you have to get the product out. Downstream processing, right? Purification, formulation. Does containment get trickier then, or just different?
I'd say different, but the need for it is just as critical, maybe even more so in some ways, because you're handling more concentrated material sometimes. Downstream processing, yeah, that's where you take the broth from the fermenter, recover the product you want, purify it, get rid of everything else, and then make it into a stable, usable form, like a powder or a liquid for injection.
So from raw mix to final product.
Exactly. And you use various techniques: centrifugation to spin down cells, filtration to remove particles, chromatography to purify based on specific properties, maybe drying at the end. Each step needs careful handling and containment.
So you need special equipment for that too.
Yes, absolutely. Specialized containment equipment is designed for these stages. For example, centrifuges, especially for biohazards, often have sealed rotors. Prevents aerosols or liquids escaping during the high-speed spinning. Filtration systems are built with containment features. They physically trap the particles you want to remove, keeping them confined. And things like chromatography columns, which can be quite large, usually have spill trays underneath. Again, catching potential leaks, reducing risk. It's about engineering safety into every piece of hardware.
And cleaning everything between steps must be vital.
Non-negotiable. Decontamination procedures are rigorous. You have to thoroughly clean and sterilize equipment after each use. Prevents cross-contamination, ensures product purity, methods like steam sterilization again, or using strong chemical disinfectants, wiping down surfaces, cleaning inside pipes and vessels. Proper waste disposal is key. Any biohazardous waste, used media, filters, disposable equipment, it gets segregated, put into specific marked containers. And then it must be treated before disposal, usually autoclaving, sometimes chemical treatment. To meet biosafety regulations and protect the environment, nothing hazardous leaves untreated.